Math 3, Unit 7, Section 3. Okay, so today I'm not going to tell you exactly what we're doing. I just want to talk about this definition first. So it's saying something is a set of all points equidistant from a given point and a given line. Okay, so if you look at this, okay, and the given point right here is called the focus, and you can see where that given point is on the graph right here. You have a focus. And the given line is called the directrix, and that line is down here. Okay, so we're going to experiment with this definition. And so this focus is at 0, 3, and the directrix is at y equals -3. This first question, and we're going to kind of go through this in different orders, but equidistant means that every point on the curve will be the same distance from the focus and also from the directrix. So with your groups, find, and let's just start with finding a few. I don't think we're going to do completely 7, but we're going to try to find some points that look approximately equal in distance from both the focus and the directrix. So I'm going to give you guys like 2 minutes. Okay, so in your groups, try to figure out some points that you think look like where they are the exact same distance from both the focus and the directrix.
They're the same distance from both?
I guess.
So you're so they have to be the same distance. So like this is right.
And -33 are both
But
If I choose like one of these, from here to
or like, yeah, so if you chose like this point, it would be
So I
from
guess
here to
there
here.
would be 3
But then
points,
also
right?
from here to here.
Yeah.
Yes, exactly, but.
here.
I think Brandon's right.
6 and 32.
What? Let me see. No, actually,
So you guys found one.
yeah, that one is 6, 3, 1.
Okay, so as I
-6.
walk around, it looks like everybody got this point here at 0, 0. Okay, who else knows that they found another set of points for sure? Brendan.
Negative 0, 3, and positive. Well, 0, -3. Yeah. -3, 0, and 3, 0.
Oh, we can do it like that.
Okay, so let's look at this. So we're saying -3, 0, and 3, 0. So if we were to like draw a line here, so from this point to this point, and then it would be from here down to here. Does that look like the same distance?
No.
Yeah, I don't think so either. But I mean, these are all good guesses, and all we're doing is guessing right now.
Like, you can go diagonally, and like it's 3 diagonal.
Oh, you mean like going from here to here?
Here, yeah, like that.
Yeah, I see what you're saying, but that's not the way it works, just so you know. So we're going like 2 straight down to the line from that point. So did anybody else find something that they know for sure is the same distance? Colton, I know you did.
Oh,
Okay, Gabby.
okay. I came up with this one on my own, so I'm really proud. But 6 and 3, and then -6 and 3.
That's it. Okay, so there's a 6 and a 3, and there is a -6 and a 3. Okay, so do you see how this right here is 1, 2, 3, 4, 5, 6 away from the focus? And then if you bring it down, it's 1, 2, 3, 4, 5, 6 away from the directrix in both directions. So let's go ahead and add both of these. Anybody else have like another guess? You did amazing. And everything is just kind of, we could kind of guess. Does anybody know what this is going to look like? Can you guys tell what kind of graph it's going to be from what we have?
Is it kind of absolute value?
Very good guess. Actually, it is a parabola. Okay, so the formal definition of a parabola is a set of all points equidistant from a given point and a given line.
If we write quadratic, is that okay?
Sure. What does the curve of best fit look like? And so we're going to put parabola. What would be its vertex?
0, 0.
0, 0 is correct. And so if we were to draw this, okay, so it's like curving, right? I'm gonna. Okay, so now that I've kind of drawn that curve in, do you guys see some other points that might also work?
Maybe 5, 2, C, or 3, 1.
Okay. So we know these ones are for sure, but let's some guesses, okay? So you said 3, 1 might work. What was another one?
4, 1, maybe.
4, 1, or maybe like 4, 1.5. And so these are good guesses, okay? And then it says, number 4, explain how this point meets the condition of the formal definition. So how does 0, 0 meet the definition?
It's equidistant from the focus and the directrix.
Very good. So the focus, what's this? The focus is up 3 from the vertex. And the directrix is down 3. Also, something that we're going to end up talking about too is that this distance from here all the way to this side, so it's through the focus and hitting the endpoints on the parabola, that is called the, I'm just going to kind of draw a line right there, that is called the focal chord. Okay, we're going to turn the page, but we're going to be kind of flipping back and forth. Is everybody good with this so far? Okay. Do we need something still? Got it? Okay. So part 2 here, testing your points. It says you should have at least 4 points that you cannot verify by counting distances along the grid lines of the graph. We're actually not going to test all 4 points. We're going to just test a couple points, okay? So for each of these, find the 2 distances, point to focus and point to directrix, and see how close to equal your approximations were, round to the nearest hundredth. And actually, Serena brought this up because she's like, there's no way you can do it without the distance formula, which is why we are going to basically end up using the distance formula. Okay, so let's go ahead and choose one of these points that we had approximate. And we're not going to choose 3.51 because that's one that's already over on this side. So a point, do you guys want to try 3, 1 or 4 and 1.5?
3, 1.
Okay, so let's start with 3, 1 and see what happens. So we're going to test point 3, 1. And so 3, 1 is our point, and we're going to call this P. And then our focus is this focus. So if we go back, our focus is at 0, 3. Because remember, it was 0 up 3. So 0, 3. And then our directrix, I'm going to put D, is we're going to be using the same value here. And so the directrix is going to be at 3, -3. Is everybody okay with that? So we're just taking 1 point on the directrix, but we're going to keep the same value. So whatever point you have for your P, we're going to use that same point on the directrix, because the directrix is actually a line, right? So we can choose any of the points that are on that line. Okay, so we're going to figure out the distance between PF. Okay, so that's point to the focus, and we're going to figure out the distance from our point to the directrix, because they need to equal each other. Does that make sense? Okay, our distance formula. We talked about this already this week, but what is our distance formula? Good. Or x2 minus x1 squared, good job, Jordan, plus y2 minus y1 squared. So we're subtracting our x's.
Math 2 comes back to haunt me.
And then subtracting our y's. Okay? So I like to always label these as xy, xy. We're going to start with our point to the focus. So we're going to label that as PF. So we take the square root question. Oh, there you go. Sounds good, actually. Okay, so we're going to subtract our x's. It doesn't matter which order you go in, but you have to stick to that order. So I'm going to go ahead and start with this, the first one. So we're going to go 3 minus 1 squared plus, and since I started with this x, I have to start with this y. So we have 1 minus 3 squared. Okay? Are we good with that?
Wait, so you took the...
So since I started with this first point, I put that 3 minus, just kidding, 3 minus 0. Wait, oops, 3 minus 0. Oh my goodness. And then because I started with 3, then over here I have to start with 1. 1 minus 3. Okay, do we agree with that now? 3 minus 0 squared plus 1 minus 3 squared. Okay, 3 minus 0 is 3. And 1 minus 3 is negative 2. So we have the square root of 3 squared, which is 9, plus negative 2 squared is 4. And 9 plus 4 makes 13. Good. Okay, so that's the distance from our point to our focus. So now we need to figure out the distance from our point to the directrix. Okay, so we're taking the P value and this time with our directrix value. So we have the square root, and again, whatever x we start with, we need to make sure we start with that on the y as well. So I'm going to start with the point, the P. So we're going to go 3 minus 3 squared plus, what'll be the y's? 1 minus a negative 3 squared, so be careful with the double negatives. Okay, so we simplify. 3 minus 3 is 0. These two negatives make a positive, so we end up with 4. And so we have the square root of 0 plus 16, and so that's root 16. And root 16 is 4. Okay, root 13, let's just check, is approximately 3.6. Okay, and so while these distances aren't the same, and like here, they were 0.03 off, which is way closer, we are 0.4 off here. The difference between those. So that means that this is not on my parabola. Okay, that won't work. Okay, so let's try another one. So we're going to test the point. Should we do 4 and 1.5? Okay. So our point is 4 and 1.5. We know that our focus is 0, 3. And so what value am I going to use for the directrix? 4 and negative 3. Good. So we keep the same x value because we want that point to match, because it has to be the same distance, right? And then negative 3.
If that had been Noah walking in, I swear.
Okay, so I'm going to let you guys go ahead and talk through this in your group and see if we all come up with the same answer. So I'm going to have you try this one on your own. teaching a class. But I can give you the stuff you missed yesterday. Mrs. Greer just wants to help. She's available. I just that's the homework from yesterday, and then this is the notes from yesterday. No, you guys are fine. Or you can go to fires too. Okay. Did you guys get it? Need more time? Oh my goodness. Bless you. Oh. Okay. I'm going to start. If you're not finished, that's okay. Just keep going. All right, so I'm labeling these X and Y and X and Y. And so for PF, we have the square root. And can somebody tell me the values that they used for PF? How you wrote them?
Square root of 4 minus 0 squared plus 1.5.
4 minus 0 squared plus?
1.5 minus 3 squared.
Good. And so we have 4 minus 0 is 4. 4, and then I'm just going to write this here. 4 squared is 16. Plus 1.5 minus 3 is? And when you squared that, it made 2.25. And so we add those together, and we get 18.25. And when you took the square root, what did it equal approximately?
4.27.
Good, 4.27. Okay, so now we're going to do the point to the directrix. And so that is the square root of, and can somebody else give me those numbers? 4 minus 4 squared plus
1.5 minus negative 3 squared.
good. And so two negatives there end up making a positive. Okay, so 4 minus 4 is 0, so we have the square root of 0 plus 1.5 plus 3 is 4.5, and when you squared 4.5, you got 20.25. And so we have the square root of 20.25, which is approximately equal to 4.5. So that one had a difference of 0.23. So it's closer, but is it exactly on the line? No, or not line, parabola. Okay, we're going to move on now to part 3.
So the one they gave us example of, would that be considered on the line?
Nope.
No?
Mm-mm.
Okay.
It's still off. It's still not exact. Yeah. Okay. So, using the definition to get a formula for the parabola points, we want to find the points P, X, and Y that will give exactly equal distances. Okay, so if our focus is 0, 3, D is a point on the directrix, but remember it's always going to be an X value and the X value of the point we choose. Remember? So I'm just going to leave that as X because it's going to change. Okay, so if we're trying to find the point, this is our formula. Okay, so we want our point to the focus and our point to the directrix to equal each other, correct? We want them to be exactly equal. Are you guys focused here? Okay. So we want these to be equal, okay? So we don't know what point to use. So I'm going to give it the point xy. Is that okay? We know our focus for sure is 0, 3. And then on this side, we're going to use the same point, x and y. And our directrix is going to be whatever the x value is and -3. Is everybody okay with how these points are right now? So we're going to make a definition, okay? Or we're going to make the formula. So when we do our distance formula here, we're going to go x minus 0 for the first parenthesis, right? Subtracting our x's. So this is x, y, x, y. And so my second parenthesis will be what?
Y minus 3.
Good, y minus 3. Okay, on this side, my first parenthesis will be,
X minus X.
good, x minus x. And then the second parenthesis will be,
Y minus N.
good, y minus a -3. Is anybody confused by what we've done there? Okay, so now we're going to simplify, okay, and we're going to take this one step at a time. So we have the square root. X minus 0 is what?
X minus
It's just x, right? Do we agree? Okay, so I have x squared plus, and then y minus 3 squared, I'm just going to leave it as y minus 3 squared, equals, and x minus x is 0, so we can put the square root of 0 plus, and this will make a what?
Y plus 3.
Good, y plus 3 squared. Now, how can I get rid of the square roots? What do I need to do in order to get rid of square roots? Good, square both sides. So when I square both sides, I'm getting rid of the square roots. So that means that on this side, just coming out is going to be x squared plus y minus 3 squared equals, and over here, 0 doesn't mean anything. Can I just write that as y plus 3 squared? Okay, questions here? Okay, so now we're going to simplify. So I need to multiply out y minus 3 squared, and I need to multiply out y plus 3 squared. Okay, so I still have x squared plus, do you guys know what this multiplies out to be? What will it be? Good, y squared minus 6x plus 9 equals, and then over here, this will be, good. Okay, now we know that if we have the same terms on both sides, they end up doing what? Canceling out. So a y squared and a y squared would cancel out, because if I were to subtract y squared to both sides, they cancel out, right? What else will cancel out? No, not the plus 6 and minus 6, but the 9s will. They have to be exactly the same, because I would subtract 9, it would cancel. Now here, if I want to put the x's together, oh, these aren't x's. I'm sorry, you guys. These are supposed to be y's, correct? I know, I'm sorry. If only I could be perfect all the time. Okay, so I want to get all the y's together. I'm going to go ahead and add 6y to both sides. And so what ends up happening with the y's? They make 12y. Very good. So the only thing I have left over is my x squared. So I have x squared equals 12y. And then more often we see this where y is by itself, right, for parabolas. And so I'm going to go ahead and divide by 12 to both sides. And so I get y equals, and I'm going to write this as 1/12 x squared. And so we're going to write this on the equation, y equals 1/12 x squared. So now that I have a formula, I can choose an x value and find the y value, and it will work. Versus guessing. What's more fun? Formula or guessing? Formula, you know, will always work, and you don't have to use the distance formula to make sure it works, and you just keep trying and trying and trying, and nothing ever gets close enough. Or you can just plug a value in here. For instance, like what could be a value I could plug in here?
0.
Well, 0. We already know 0, 0. I could plug in 1. What's 1 squared? 1 times 1/12 would be 1/12. So an ordered pair then could be 1, comma, 112. I know for sure
That's gross.
that will end up working. Does that make sense though? Okay, so test these points you know are on the parabola. So all we're doing is plugging these values into the equation. Okay, and so this is your x and y. And so if we plug them in, we have 0 equals 1/12 times 0 squared. And that makes 0 equals 0. Checks out. Okay, let's try 6, 3. So again, we have x, y. So we will have 3 equals 1/12 times 6 squared. What's 6 squared? So 3 equals 1/12 times 36. So 3 equals 36 over 12. And does that reduce to 3? Yes. Checks out. Okay. Same thing. X, y. 3 equals 1/12 times negative 6 squared, which we know negative 6 squared is going to be 36. So 3 equals 36 over 12, which we know makes 3. Checks out. So using the equation, can you think of any other points that will be on the parabola? So we already thought of 1, right? We got 1 and 1/12. Could you guys plug in any values? Yeah. You know what a good one to choose is? Like 12s. Because if you want them to be like whole numbers, if you choose a value of 12, it'll end up canceling out one of the 12s. And so if I were to use 12 for x, what would y end up being?
1.
Very good. Oh wait, not 1. Let's try again. Because we go y equals 1 over 12 times 12 squared, right? So we're going to end up getting y equals 144 over 12, which
12.
equals 12. Good. So 12, 12. Now, think about your parabola. If you have a point, okay, going back here, okay? If I have a point over here at 12, and then it's going up 12, that means there's also going to be a point at negative 12 and up 12.
So that means there's one at negative 1.
Very good. So that means there would be one at negative 1 and 1/12 as well. Okay. Yes? Were you okay with this? All right. We are going to stop at this point for today.